Hello and welcome to our video about our drone launching system and how other teams can build similar drone launching systems. As you can see from our drone launching system, it uses one servo that has a flat piece on it that is able to hold back the tension that is created from the rubber bands that we have mounted, as you can see here. Whenever a paper airplane that is inserted into the slot here and the servo is rotated, the rubber bands are able to shoot the paper airplane into any of the three zones. This is very beneficial for teams because paper airplane shooting in endgame is one of the biggest scorers in points right now, with the maximum being 30 points, and can easily boost your team for either your state or your regional competitions point score and help you advance further in the game. Your paper airplane shooter does not have to be made out of metal like ours is though. You could also 3D print your shooter using either a custom made part or parts that are already found on FTC 3D print sharing websites. Additionally, remember whenever you're making your airplane, that it is best to have your airplane fit inside the shooter, almost like this, and have this length of a paper airplane or whatever your shooter's length is, so you don't run into problems whenever your paper airplane gets knocked out. Additionally, remember whenever you're making your paper airplane that the airplanes have to be red and blue with the color matching the exact tape that is used in the game. A problem that was seen across a lot of qualifiers was teams did not have properly colored drones and either had to remake them using paper there, or were not able to shoot their drone at all. Additionally, the team number has to be visible on the plane itself.
Hello, I'm Cameron, and I'm here to explain some of the physics principles you can apply to improve your drone design on your robot. First, we're going to start with Hooke's Law. So, a lot of the teams have been using springs or rubber bands, which act with elasticity, which can be applied with Hooke's Law. The force of launch is equal to the spring coefficient times the x distance brought back from its equilibrium position. Here, with us, we had 3 rubber bands attached to our servo, pulled back only a small distance from the equilibrium position. In order to get that power to launch above both the garage doors and the back wall of the playing field, you have to get a lot of force to secure this launch. And there are 2 ways you can go about this. For example, we really didn't pull the rubber bands back that far, but we layered them. This increases the value of K, the spring coefficient. Increasing this allows for the launch force to be more, so you have more power to launch over these walls. Another way you can do this is by extending your drone launcher. By doing this, you can increase the distance or the X value in Hooke's Law, so you can launch with more power by just simply pulling the rubber bands back a farther distance. Another thing you have to keep in mind when it comes to your drone launcher is the angle. With these longer drone mechanisms, it's going to be hard to angle yours up. And in order to do that, you have to angle it up to get above these garage doors, because you have to launch above the garage door and also above the back wall. So it has to be at a reasonably steep angle. And with these higher drone mechanisms, I noticed with a lot of teams, they angle it, but the angle is often too high for the robot to freely go under many of the field mechanisms, like the garage doors or the other obstacles at 12 or 14 inches. So a good way you can combat this if you have a longer drone launcher is by putting your drone launcher on a motor. By doing this, you can angle your drone launcher at the end of the match and keep it flat for the rest. This will keep your robot under the desired height and make sure it can navigate freely on the field. Another way is just by using this shorter type drone design. And doing that, you can keep it at this higher angle more permanently, use up less motors than you would if you kept it on a motor, and just have it better for force and velocity. However, one thing you have to know is you have to keep the angle reasonably high, because although sometimes if you keep it at a lower angle, like 15 or 30 degrees, it will get above the back wall. But you have to remember, in order to get full credit of points, it also has to go over the garage doors. So the things you have to remember are the spring coefficient and just getting it above a certain angle. So you make sure you meet all the requirements to get the desired points and hopefully get your 30 points max in drone launching stages.